Look up on a clear day, and the sky is blue. It always is, and we barely even notice it. But why exactly is it blue? Why not green, or purple, or just plain white? It is one of those simple childhood questions that, for centuries, almost nobody could really answer. To solve it, we have to start with sunlight itself. Sunlight looks plain and white, but that whiteness is hiding a beautiful secret. Tucked inside it are every single color of the rainbow, all blended together at once. Over 350 years ago, a young Isaac Newton proved exactly that, alone in a darkened room. He let a thin beam of sunlight pass through a simple glass prism. And the white light fanned out into a glorious band of color: red, orange, yellow, green, blue, and violet. White light, he had shown, is really all of the colors mixed into one. But to understand the blue, we need one more idea. Light travels in waves. And each color is really a wave of a slightly different size. Red light rolls in long, lazy, stretched-out waves, while blue and violet light come in short, tight, choppy little waves. So how do those tiny waves end up painting the entire sky blue? The answer came from a British scientist named Lord Rayleigh. Our air is filled with countless tiny molecules, far, far too small to ever see. As sunlight pours in from above, it constantly crashes into them. The long red waves mostly sail straight past, barely bothered at all. But the short blue waves get knocked sideways and flung off in every direction. This endless bouncing of blue light is now called Rayleigh scattering. So blue light gets sprayed right across the sky until it seems to glow from everywhere at once. And that is the blue you see. It is simply scattered sunlight, raining down from the whole sky. But wait, violet waves are even shorter than blue ones. So why isn't the sky violet? There are two reasons. The sun gives off a little less violet light to begin with. And your eyes are simply far more sensitive to blue than they are to violet. So your brain quietly blends it all into that one familiar shade of sky blue. Now for the truly beautiful part. Why do sunsets melt into red and orange? At sunset, the sun sits low, and its light must travel through far more air to reach your eyes. Along that long journey, almost all of the blue is scattered away and lost. What finally survives the trip are the long red and orange waves. And that is why the setting sun sets the whole sky on fire. It even explains other planets. On Mars, the thin and dusty air scatters light quite differently. So the Martian daytime sky looks a dusty butterscotch, while its sunsets glow an eerie blue. So the next time you look up, just remember this. That blue is not really the sky's own color at all. It is sunlight, split into waves, and scattered by the ocean of air all around you. A hidden rainbow, quietly painting the sky every single day. So, what should we wonder about next? Tell me in the comments, and subscribe to Sketch Science.